Hey, all you Hamilton fans, this is about take 3 on this, so hopefully this is better. I certainly learned a lot as I've been doing this, and how to make some of these Desmos and Excel work for us. So we're going to talk more about differential equations today. Slope fields, we're going to talk about that. You may remember that from Calc 1. We're going to talk about numerical methods. Both of these are ways to solve differential equations. When we talk about numerical methods, we're specifically going to look at Euler's method today. All right, so let's take a look at slope fields, and we're going to pretty much exclusively do this on Desmos. Right, the book is going to ask us to graph some of our own slope fields, but we're going to see how that works. So let's go to Desmos here, and here's a slope field generator, and we'll find that as we go. So what we have is we have y prime equals 2x over y. Right, we have y prime equals 2x over y. All right, and so what's happening here, you see we have a movable point. So here's my point, it's what's movable. So watch over here the A and the B, and then watch down here. All right, so what's going on there? So let's match it up right here with this point right there. That point we're going to make -2 and 3. Okay, so and you can see there that little black point that I had, its little tick mark or whatever there matches exactly what's there. Well, what is that? Well, that is the slope at that point. So 2 times, what happened? 2 times -2 divided by 3. The slope is -4/3. The slope is -4/3 if we make that a fraction. Right, and so this little bit right here is going downhill at -4/3. Watch what happens if I move it over here when x is 0. All right, when x is 0, okay, when x is 0, my slope should be 0. So it's exactly 0 right there, right? So when I plug in 0 here, my slope is exactly 0. That's what's happening on this slope field generator. All right, I've taken way too much time. I'm having too much fun with this Desmos. This is just fascinating. But all of these, what all of these are slopes. So if I move the point to here, according to this right here, that slope should be doing that right there. It should be going downhill. All right, let's go back to here. Let's solve this. All right, so if we solve this, okay, y prime is 2x over y. I'm going to make it dy over dx is 2x over y. And you can see I move the dx here and I move the y there. So I have the integral of y dy, that's a dy, equals 2x dx. When I take that integral, I get 1/2 y squared equals x squared. And I just chose to put the constant on this side. Remember, I had a constant here, but I'd have to move it over here. All right, now I'm going to solve for y. I get y squared equals 2x squared. If I multiply a constant times 2, I still get a constant. Now when I take the square root, I get positive or negative the square root of 2x squared plus c. So let's go back to Desmos and look at our 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 slope field here. So I'm going to put 2x squared plus that constant inside here, and I'm going to add that constant there. Right now it's equal to 1. Right, and so what's happened is that is the graph when c is 1. So you see right there, it flattens out right at 0. Okay, so notice what happens if I make c bigger. It rises. Okay, now here's what's fascinating. I'm going to go to a negative, all right, and see what happens when it's negative. It now splits. All right, it now splits. And what I want you to see at this point right here, that point right there, that y value is 0. So if I divide by 0, I'm going to have a vertical vertical slope, all right, or an undefined slope, right? And so that's what's happening right there. So as we move those points, okay, as we move those points, they're vertical right here, but they match up these slopes as they go here. So the graph of these slope fields tells us where the graph is going to be. I think most of us probably saw this here, but we don't see this one out here. Now, what about down here? I haven't seen anything down here. Now, recall that this was positive or negative. So it comes down here. Let's see if I can get it to match out there. Not real well. All right, so notice as I come here and I put that point right there, see my graph matches up exactly with that. So let's move, all right, and let's make C positive again. All right, and so let's make C positive again. And as I'm along this line here, notice that my graph matches up real well with wherever I move that. All right, as I come here, see that graph just keeps matching up, all right? And as I'm here, it's horizontal. I just think this is fascinating. All right, so a slope field kind of helps us see what the graph is. It doesn't necessarily help us to see what the actual equation is, all right? But it helps to see what the graph is going to look like. And we can sketch that graph, okay? So let's go back. Let's look at Euler's method today, okay? So let's choose a different function, okay, or a different differential equation. Y prime equals 2x minus 3. And hopefully you know that when we take that antiderivative, we get x squared minus 3x plus c. Now remember, this is an initial value right here, okay? This is an initial value, which means that we have 0, 3 right there, okay? So if I plug in 3 for y and 0 for x, I'm going to solve for c. We get c equals 3. So my particular solution in this case is y equals x squared minus 3x plus 3. Okay? So I've done a lot of work already. Okay? Let's talk about what Euler's method is, and then let's talk about what all of this right here means. Okay? So what I've done, what I've chosen to do, is I've chosen to let h in Euler's method be 0.1 and n equal 10. So basically, and I'll show you this, the smaller h is, the better results we have, and the bigger n is, the better results we have. All right, so our initial condition, this was our initial condition, okay? I lost my initial condition over here, but my initial condition is this right here. My initial values, x0 is 0, y0 is 3. Now watch what happens, okay? X sub n, all right, so x sub 1 equals 0. Now, n is going to change, all right? This is my maximum, max n value that I report here. That's my max n value. But notice my n is 1 here, so it matches right here. So I always use x0. x0 is 0 plus 1 times, this is my h value right here. So that's 0.1. All right? And then y1 is our previous y value. This is the previous y value. That's super important. Notice the difference here. This always goes back to the initial x value. This goes back to the previous y value. All right, the previous y value. So my previous y value was 3 plus h is 0.1. And then I got to plug in, it's really f of 0, 3. So that's plugging it back into here. Well, what happens when I plug in 0 here? 0, I get negative 3 right here. So 3 minus 0.3 is 2.7. Okay? Now let's keep going. x2. x2 is 0 plus 2 times 0.1. That's 0.2. And then I take my previous y value, 2.7, plus my h value right here. So this is the previous, this is y1. This is h. Now where does this come from? This comes from plugging in, now I'm going to plug in 0.2. Nope, I'm sorry. I'm going to plug in the previous x value. I lied to you. So this is 0.1, the previous x value. Helps if I remember what I did here, 0.1. And so when I plug in 0.1, I get 0.2 minus 3. That's negative 2.8. So this is y prime of x1, if you will. All right? So when I do that, I get 2.42. Now, this has taken me a lot of time just to explain all of this. It's going to take a lot of time to do all of these exercises. So let's go to Excel and see what happens. So what I've done is on Excel, I've already calculated, there's our initial condition. This is our x1, y1, and this is our x2, y2. And what I've done, and I'll show you this in class, I've already put in the formulas for all these. You can see them up here. You can see them up here. I've put in everything, okay? And so then what I've also done is what I copied, all right? I'm going to copy, and I'm going to paste it into Desmos. And so you can see here, let me turn something off here, that I'll show that here in a second. What you can see here is I've copied this into Desmos, and what I've also done is I've overlaid it with the actual solution. Don't worry about everything else here, right? This is just using somebody else's stuff, all right? So there is our particular solution. So I've overlaid it. This graph right here is the particular solution. So notice when h is 0.1, early on it's pretty good, but then as we get further and further away, it's not so good. All right, it gets further and further away. So let's go back to Excel. And let's change our h value. Sorry, I want 0.05. Okay, 0.05. And then what I did was I copied it, and I'm going to paste it into Desmos. All right, and so now, let me keep that on actually. Okay, now my h value is smaller, so you can see my steps are smaller here. My steps are smaller, but notice they're all closer to the graph. They're closer to the graph. Okay, so what I've done here is by using a smaller step size, I've actually approximated the solution. Okay, so what I've given you is just a real basic overview of Euler's method and how to use it, and how we're going to see it on Excel, and how we're going to see it on the graph on Desmos. I haven't given you much of anything how we're actually going to use it. I think I'll save that for class for our exercises, but at least you can kind of see what we're going to do in class, and how we're going to possibly use it, not necessarily how we're going to get solutions. All right. Hey guys, I appreciate you watching. I know this might have been tough to see, and especially since I've gone way over time here. But I thank you for watching. We'll see you in class.